Hello, everybody, and thank you for joining Energy Storage Solution presentation for the data centers. In today's session, we will have a look what we have offer in ABB side for battery energy storage. My name is Tanel Türk, and I'm the solution portfolio manager for ABB in data centers. And I'm here with my good colleague, Carlos.
Hello, everyone. Thank you for attending. I'm Carlos Nieto, the Global Product Line Manager for Energy Storage within ABB. And we would like to introduce you what we do within ABB Energy Storage Solutions to support the transition to sustainability in data centers.
So today we will have a look how to make data centers more sustainable, how the battery storage can help that, and how the backup power has involved in the past. If we have a look in the ABB portfolio in general, everybody knows that ABB is one of the top leaders in electrical equipment supplier. We do have a portfolio from the medium voltage down to the low voltage and also in the critical power as well, the different applications that we provide. But we also have to support the sustainability. We have the motors and the frequency drives. And so if you look at landscape, there is a relatively wide portfolio and comprehensive that ABB can offer. If we have a little bit deeper look on the data centers and the critical power as application, traditionally there has been more low voltage UPSs in the past, and there has also been the development of the rack level UPSs. But the future, as the power electronics are developing, we're moving more to the medium voltage, having an application as a medium voltage UPS and the battery storage, which is coming very rapidly and used in a lot in data centers. But we also need to keep in mind sustainable point and the diesel gens are changing the fuel to the more sustainable, and also the fuel cell technology is developing very rapidly to provide really the clean and clear power to the data centers. So in this session, let's have a look a little bit more on the battery energy storage and how we can make the data centers more sustainable. Carlos.
Thank you, Daniel. I would like to start saying how can energy storage benefit data centers? So we have to look from different angles. One is the backup power source that we have inherently in battery energy storage, which can help to delay the start of the gensets, which is going to reduce the CO2 operation of the facility, or we can replace fully gensets, having emission-free operation. As well as we have an battery energy storage or energy storage coupled with renewables, they can be integrated into the energy mix in the most optimal way. We have as well the possibility to reduce the capacity of the UPSs, which is going to save footprint in the gray space. We will see one of the use cases in this matter. As well, the battery energy storage is a grid interactive system, so it can provide ancillary services to the grid, which is going to generate an additional revenue stream for the data center operator. If we look at the technologies that we have in the landscape of energy storage, we can have from mechanical, electrochemical, and electrical. If we look at the system power from the range of kilowatts up to dozens of megawatts and durations that basically goes from few minutes up to hours, we can see how lithium-ion batteries are covering most of this landscape. So during this presentation and in the energy storage solutions, we are working today with lithium-ion batteries. We've been talking now about energy storage, but I would like to explain the rationality of energy storage for data centers. In the present days, we have a boost for decarbonization in and data centers. They are one of the more energy consumers in the world. So, and those data centers have set up ambitious targets, which in some cases aim for even for net zero. This is going to lead to two main streams: more renewable generation, including PPAs and on-site generation when possible, and the reduction of emissions by cutting off genset operations. These two streams present a challenge for the data center industry, which are linked to the grid stability and the mission critical of continuous power for operations. With battery energy storage, these challenges can be tackled. It can optimize in one side the self-consumption by optimizing renewable generation, providing as well grid stability, but they can also run as a backup power source. If we look when they are running as a backup power source, if we consider that the BESS can replace a diesel genset, the savings are considerable, with an estimate of 180 tons per megawatt for a lifetime of the equipment of 15 years. We will look into the detailed use case for this statement that we have here. One of the key values of the BESS is that opposite to a genset, which stands idle 99% of the time, the BESS can provide additional services for the grid by just being online. This is going to generate an additional revenue stream. The battery energy storage is 100% compatible with other energy sources in the data center, such as PV and wind or fuel cells, diesel gensets, the grid. All the energy mix is compatible with the BESS. The BESS is much faster than that genset, so we can reduce by 90% the UPS backup needed time. At the same time, and we will see it, we have a 50% footprint savings when using ultra capacitors that they are enabled by using the BESS upstream, the UPS. We can also couple artificial intelligence or machine learning into our system, and we can add that intelligence that it can be used to optimize the operational parameters of the energy storage, having a 10% increase of battery lifetime. In our portfolio, we have two main streams. One, a small scale e-storage flex up to 3 megas, and e-storage max, which is just a building block which can go from 3 megas up to the range of the dozens of megawatts. If we look at the use case number one that we have here today, the BESS is set up to delay the start of the gensets. So we are going to support those short grid outages up to the duration basically of several minutes or within an hour. The system architecture, the BESS is going to be connected basically in parallel with the genset and with the grid. And we aim here, we have calculated, you have here the assumptions that we have considered: 1 megawatt as power unit, 2 megawatt hours of energy needed. We consider 2 outages a year and 1 hour of those outages as a duration. So we get CO2 savings of 26.1 tons per megawatt. The key considerations that we have to consider here is that the BESS, as I said, is added to the standard system with a lithium-ion battery capacity from 1 to 2 hours. So in case of a grid outage, the system is going to transition to island operation. And during that transition, the UPS is backing up the ID load. The BESS is then operating as a grid forming mode and is setting up the voltage and frequency on that isolated grid. Below a defined state of charge, which it can be set up by operator, the gensets are going to start and they are going to work in parallel with the BESS. But we need to consider that here the spinning reserve can be provided by the BESS. So we can maintain an optimal speed of the genset in terms of fuel consumption and CO2 emissions.
Carlos, this really seems interesting and seems the right direction. One question here: how fast can it transition to the islanding mode? Can you
I would say, Daniel, yeah, you just hit the million-dollar question. It's a question that we receive basically every day. It's not a matter on the speed on how the BESS can go. We have to consider that we are not as an UPS. We don't have a bypass. We are totally connected in parallel. So the energy storage can pick up a load within 20 milliseconds at full load, but we have to consider that we have breakers upstreams. So we have to consider the opening time of those breakers in order that we don't feed a possible fault upstream in the system. If we have to say a number, we would like to stay below half a second.
Very good.
So in the use case number 2, before we were putting the BESS in parallel with the gensets and reducing the time that these ones are going to operate, just covering those short outages. In this use case number 2, we put the BESS to replace fully the gensets. Savings are much longer because the gensets will not run even for maintenance. So we have a total saving of 180 tons of CO2 per megawatt. In this case, of course, the considerations that we have to bear in mind is the capacity in the BESS is going to be much longer. Normally, we are considering between 2 and 8 hours duration. In case of grid outage, it's the same as before. The system is going to transition to island operation. UPS is backing up the load, the IT load during the BESS start. The main thing we have to consider now is that below a defined state of charge and still under great outage, if possible, the data center has to transfer the IT load to another server because the batteries are running low and we are going to be offline in a point. But if we consider what we can do, we can add a fuel cell into the system or any other source. The fuel cell is going to be connected as well in parallel with the grid and with the BESS. So this fuel cell can provide the long duration energy backup that is needed. If the fuel cell is there, it's not that the main thing is that the BESS can be then reduced in energy capacity. We don't need those 8 hours. With the 1-2 hours that we had before in the use case, number one is enough because the fuel cell will run in parallel with the BESS. The BESS will always be in charge of generating the voltage and frequency in that islanded grid that is needed for the fuel cell to inject the current.
Very good and very interesting again. Carlos, can you elaborate a little bit more on the fuel cells? What kind of fuels we can use for this purposes?
The fuel cells, in terms of fuel, we can use different fuels from methanol to crack ammonia on site if we have enough, let's say, power to crack that ammonia and obtain the hydrogen. That energy, we will normally get it from renewable side in a microgrid structure. And from ABB, as of today, well, there are different suppliers. We are not tied to one single manufacturer of fuel cell, and we have different initiatives with them as of today.
Very good, and this will really help the data center also grow and use in the different power. So that's really good.
Absolutely. So we have 2 use cases. One is to delay the start of the gensets. The other one is to replace fully gensets, but we have additional benefits, as I was pointing out before. When we have battery energy storage in our energy mix in the data center, one is the footprint savings in the green space. If we consider today, let's talk about 1 megawatt backup power. Normally, those servers will need 5 minutes of capacity installed in the UPS until the genset is up and running and online. We need mostly 6 UPS battery racks behind that in order to achieve that power and duration. If we have the BESS, as we said, we can pick up the full load, breakers opening, islanded operations within half a second. So we do not need the range of minutes. In order to get a backup power of 1 megawatt and 30 seconds to be on the safe side, we can change the technology that is on the energy storage of the UPS, and we can move to ultracapacitors. If we move to ultracapacitors, we can see we jump from 6 battery racks to 3 ultracapacitor racks. So we have 50% footprint reduction when enabling the UPS other technologies. At the same time, as I said, the BESS is always online. We don't have to have it offline just for backup. The batteries, lithium ion, they like to be cycled, is better for the lifetime, and we can as well generate revenue. The BESS is considered then as an investment. We don't have idle time, and we can participate in monetization programs like time of use, fast frequency response, peak demand management, or capacity aggregation. Of course, we are talking now different considerations like running in parallel with a genset or running in parallel with a renewable source, fuel cells, grid services. We need a digital layer. That digital layer is part of the battery energy storage as well. And this energy management, monitoring and diagnostics, we have it in different levels. We can have it on premise, where we have all the smart and connected products like hardware, digital assets, and the electrical infrastructure. One level up, where we plug our portfolio from our portfolio, the e-storage OS. This is a digitally enabled solution. We can integrate the renewables, the storage, grid support, substation automation, as well as multi-energy optimization. But of course, we know in a data center, we have the built-in management system, where there is going to be a link between the storage OS, the digital layer of the battery energy storage, and this built-in management system, which of course fulfills the higher levels of cybersecurity, can have analytics, reports, and the algorithms in order to control facility as well as the BESS.
Thank you, Carlos. And let me add a little bit on this one. Definitely, the going to digital is most important thing. So, but if you look from the ABB side, there are different levels that we can do on digitalization and automation. We can integrate all different renewable power and sustainable power ways. We can do also the connect EV chargers and so on to the system. But then we can also take it to the one level up in the unit level as a microgrid. We can connect the low voltage switchgear and the medium voltage switchgear and the power PCS units as well. Or we can go to the level 2, which is more on the system side as well. And then on top of that, we can add the layers with ABB SCADA and connect it to the how it's needed, as the data center usually would like to have on-premise systems, can be connected that way, but also can be inputted to the cloud to manage different data centers around the world or in the different distances. So ABB digital layer comes really with the different levels. One thing to really keep in mind, if you invest today on the switchgear, keep in mind that in the future, if you want to control it, want to monitor it, and really want to do it on the distance, start thinking about already today on the digital layer and how would you really try to implement that. When you purchase the switchgear beginning with the digital components, it's easier later on the journey how to implement and go in a more sustainable. So if we have a look also, just as a wrap up a little bit, the data centers used to be only consumers. They used to be a one-way energy transition. But today we're looking data centers, they are coming prosumers. There are more generations or renewable integration inside the data center and around the data center. If we add now more the battery storage or the fuel cell, so it's a little bit of change in a concept that used to be in the older time. And here we do highlight the number of benefits that the battery storage will add. And let's just recap a few of the most important ones. Carlos, what can you tell regarding reliability? How will battery storage really help here?
We need to consider the variability and the intermittent nature of that renewable energy that we can have on a microgrid-enabled data center. So the microgrid-enabled data center architecture requires reliable technologies and, of course, the intelligent control to ensure a proper power sharing under grid-tight conditions, but also reliable power during islanding operations. So transitions from grid-tight to islanding operations, they are critical, and vice versa. And those are initiated automatically. There is no need for an operator to trigger that jump. Of course, if desired, it can be done. But the control system of the microgrid is going to be responsible for isolating from the grid and resynchronizing with this one from one condition to another. So the battery energy storage, when islanded, is going to prevent those large frequency deviations under the islanding conditions. And it can as well perform a full black start if it's needed.
Very good. Let's take another most important element from this formula is the sustainability. Can you elaborate a little bit this one?
Yeah, very good, Daniel. On the sustainability, regardless, let's say, of the steps taken to use more efficient equipment and to conserve energy within a data center, the challenge that remains is the transitioning to a clean, renewable energy. That's the key. This transition is enabled by a microgrid architecture that is going to control that energy mix within the facility through renewable on-site generation, but always coupled with battery energy storage to optimize efficiency. We want to use the energy coming from the renewable in the most optimal way. The capacity installed in a battery energy storage integrated within the microgrid of a data center is going to provide the needed backup power without starting the gensets, as we said, immediately after a grid outage, or as we saw, they can even replace gensets.
Right, and also we cannot really skip the most important one is the revenue, of course. And as I said, data center used to be the one-way consumers. Now it comes prosumers and giving back something for the grids and a little bit helping the society. Can you a little bit more give just to highlight the revenue stream point as well?
Sure, Daniel, as you are saying, and we all know money talks. So we are here for the business. And if we look at it, as I said, genset today is a cost. You just have it there idle. Normally, in some of the cases, it can be that in some cases, they start gensets to provide grid services. This is not the target if we consider the previous point on sustainability. When we have a BESS in the microgrid, we have renewable. We can participate in different monetization schemes for additional revenue streams or even cost savings. These are possible due to the versatility of the microgrid for data centers, either by additional streams or by cost cutting. The return of investment of a microgrid-enabled data center can be readily realized. Grid services can be easily provided by just having a battery energy storage within the microgrid concept in terms of reactive power support and fast frequency reserves. This one is going to automatically enable the additional revenue stream to support the operations of the core business of the data center.
Thank you, Carlos. And I think we have went through really the good journey where the technology has headed in the past. What do we have today available? How can we tackle a little bit more the sustainability, reliability, and also give additional revenue streams for the data centers? So I think it was a little bit brief discussion, but also gives a little bit direction where it goes. We're happy to support from ABB side with all the portfolio and battery storage, and really show the complex and the different systems can help you on your data center journey. So feel free to come back to ABB. We are always happy to support here, and definitely, Carlos, thank you for your insights here. And I think this is the way we can move forward.
Thank you, Daniel. Thank you, everyone.
Thank you, everybody. Bye.